Hello grade 12s, welcome to this final exam preparation video. This is the third video of the series, and the topic that we'll be discussing here is differential calculus. Let's take a look at the question. Okay, so if you look at the questions and really understand them, you will see that obviously the topic there is differential calculus, as I mentioned. However, the first question, we are asked to use the first principles to get the first derivative of this function. Okay. Second question, we are asked to get the equation of the tangent to this function here that we're going to get the gradient for. And B1, here I'm going to use rules of differentiation, and B2, again, rules of differentiation. However, we understand that in these situations, there is usually preparation that is needed before differentiation. Okay, so we'll get there. Let's look at the first one. First principles, this equation or the principle itself is in the formula sheet. So there's no reason for you to get it wrong in the exam. Okay, what do we start with? We need the expression for f of x plus h. Okay, whenever there's x, we are going to substitute x plus h. So there are two terms that contains x, so let us be careful there in our substitution. Okay, what do we need to do here? We need to expand. So we're going to have an x squared plus 2xh plus h squared in the brackets. Then you need to distribute the negative 5. So you end up with negative 5x squared minus 10xh negative 5h squared plus x plus h. Okay, are we ready to take it to our equation? Yes. So f of prime x is equal to limit as h approaches 0 of f of x plus h minus f of x. So usually you'll always be given f of x or g of x depending on the label of the function in that particular question, but the standard principle remains the same. So we're going to substitute this entire expression, negative 5x squared minus 10xh minus 5h squared plus x plus h minus what? F of x. This is a binomial, so we introduce brackets. Negative 5x squared plus x. What is this over? It's over h. Good. So we have limit h approaches 0, and we see that there will be cancellation of terms, and the x there, x will go there. What are we left with? Negative 10xh minus 5h squared plus h over h. Division of h throughout gives you limit h approaching 0, you're left with negative 10x minus 5h plus 1. Okay, are we ready to take the limit? Yes, we substitute 0 in there, so therefore the derivative of this function is negative 10x plus 1. Okay, so please get full marks all the time whenever you apply first principles. There are just small details like sign changes that will need to be taken care of, and brackets where there are, more than one terms or a negative term, so that you take care of that. Good stuff. Let us move on to question 2, where we are asked to get the equation of the tangent. All right, so what is given? We are given the point at which this tangent makes contact with the graph of f, right? And the graph of f, what type of function is this one? It's a parabolic quadratic function. Okay, concavity, is it concave up or down? It's concave down, right? The coefficient there is negative of x squared. Good stuff. So what do we need? We need the point of contact, the x and y coordinate, and we need the gradient at x equal to 1. So can we get the gradient at x equal to 1? Yes, the gradient of the tangent at x equal to 1 will be the gradient of the function at x equal to 1, and we have the expression that represents the gradient of this function. Yes? Good. So we have negative 10 times 1 plus 1 giving us what? Negative 9. Good stuff. What does this give us? It gives us the value of m. Okay, so the point of contact f of 1 is equal to what? Negative 5 times 1 squared plus 1 is equal to what? Negative 4. So then the point of contact is 1 and negative 4. Okay. How are we going to use this? So x and y coordinates, substitute for x and y, substitute for m. That will give you the value of c. And what does c represent? That is the y-intercept of this linear function or the straight line. Good stuff. So therefore we have negative 4 equal to negative 9 times 1 plus c, and the value of c is therefore what? 5. Okay, so then the equation is y is equal to negative 9x plus 5. Okay, great stuff. So there we are with the equation of the tangent. Let's go to question B, where we are going to use rules of differentiation. So we are asked here in B1 to get dy over dx of this equation here, or this function here. So whenever we have fractions, usually the standard procedure there is to split, simplify, and get an expression that has eliminated the fractions so that it's simpler to differentiate. Okay, so x cubed plus square root of x cubed, both of them are over x, so we're going to split them like that and have x cubed over x plus square root of x cubed can be written as x to the power of what? 3 over 2, and this is over x, right? This is called the preparation before differentiation step, right? That's why we are not introducing the dy over dx notation, because we're not ready to differentiate. Okay, simplify. What does this give us? It gives us x squared plus 3 over 2 minus 1. It gives us a half, right? So this has eliminated the denominator, and we are ready to definitely differentiate this using what? The power rule, right? And the sum rule of the differentiation rules. So dy over dx will be what? What is the derivative of x squared? This gives us 2x plus derivative of this power function. It will be 1 over 2 square root of x. Okay, so we can do that intermediate step between these two to see that you end up with a negative half as the exponent, and if you leave your answers in positive exponents or radicals, and that is what you end up with. Okay, so that takes care of B1. Okay, let us look at B2. Here we are asked to differentiate this function here with respect to x. The notation is different, and we need to use the right technique for the right notation. Okay, so what do we have? We have a difference of two terms here, and by the looks of things, it looks like what? Difference of 2 cubes. Good. And we have a trinomial here raised to the power of -1 that is there to give you a clue actually of what your factors will be here, so that cancellation can take place. Okay, so what is this equal to? This is equal to, it's the same as differentiating the following. What is the factors here? 2x minus 3, 4x squared, okay, product of this two, plus 6x, the square of 3, plus 9 over what? Exponential law applying there becomes a denominator, right? For x squared plus 6x plus 9. So can we see this cancellation happening? Yes. Okay, so what is left? We are actually differentiating a linear function from what seemed to be complex, right? So the derivative of this linear function is equal to what? It's a simple 2. Okay, so this is your section A type of questions under differential calculus. First principles, find the equations of tangents, and applying rules of differentiation in different contexts. All right, so I believe that this was helpful to you. Watch it again if you need to, and you can now start preparing for question 4. And in that one, we'll be talking about sequences and series. Great stuff. See you next time. Sharp, sharp.